Call it heads or tails. Most of us think of a coin toss as the definition of random. It's a 50-50 shot, chance, luck. But is it? If I knew the exact force of my thumb, the precise weight of the coin, the air density, the humidity, and the exact distance to the floor, the result wouldn't be random at all. It would be a certainty. If I could replicate those initial conditions perfectly, I would get the same result every single time. The coin isn't random. It's just that we are ignorant. We lack the data to calculate the outcome. So here's the scary question. Is everything like the coin? If the universe is just particles hitting other particles, obeying fixed laws of physics, does that mean the future is already written? Did the Big Bang set up a chain of dominoes that inevitably led to you watching this video right now? Welcome to the terrifying beauty of determinism. To understand if your future is fixed, we have to go back to the man who wrote the rules, Isaac Newton. When Newton formulated his laws of motion, he gave us a powerful gift, predictability. He showed us that if you kick a ball, we can calculate exactly where it will land. Imagine the universe is a giant pool table. The atoms are the billiard balls. If you know the position and speed of every ball, and you know the physics of a collision, you know exactly where they will be in 5 seconds or 5 years. This view is called causal determinism, cause and effect. In 1814, French scholar Pierre-Simon Laplace took this idea to its logical extreme. He proposed a thought experiment now known as Laplace's demon. He imagined an intellect that knew the precise position and momentum of every single atom in the universe at a single moment. Laplace wrote, "For such an intellect, nothing would be uncertain, and the future, as the past, would be present to its eyes." Think about the implications. If Laplace's demon looks at the atoms in your brain right now, it can calculate exactly what neurons will fire next. It knows what you're going to eat for dinner next Tuesday. It knows the date of your death. It knows the end of the universe. In a deterministic universe, time isn't a river we flow down. It's a frozen block of ice. The movie is already on the reel. We're just watching it play out. But if that's true, why can't we predict the weather for next week? For a long time, scientists thought that if we couldn't predict something, it was just because we didn't have enough data. If we built a bigger computer, we'd be the demon. But in the 1960s, a meteorologist named Edward Lorenz found a glitch in the matrix. Lorenz was running a computer simulation of weather patterns. He wanted to rerun a sequence, so he typed in the numbers from the previous run. But to save time, he rounded off a number. Instead of typing 0.506127, he typed 0.506. A tiny difference, less than 1,000th of a percent. He expected the result to be the same. Instead, the weather pattern was totally different. This is chaos theory. You know it as the butterfly effect. The idea that a butterfly flapping its wings in Brazil can cause a tornado in Texas weeks later. Here is the crucial distinction. Chaos does not mean random. The weather is still deterministic. It still follows physics. However, it is sensitive to initial conditions. Because we can never measure the state of the universe with infinite precision, we can't measure every atom to the infinite decimal point. We can never predict the future long-term. So Laplace's demon is theoretically possible, but practically impossible. The future is written, but we are forever forbidden from reading it. At least, that was the consensus. Until the 20th century, when physics decided to get weird. If you zoom in close enough, past the cells, past the molecules, down to the subatomic particles, Newton's laws break down. Welcome to quantum mechanics. In the quantum world, things don't have definite positions until you measure them. An electron isn't a billiard ball. It's a wave of probability. Werner Heisenberg introduced the uncertainty principle. It states, fundamentally, that you cannot know both the position and the speed of a particle at the same time. This isn't just about bad measuring tools. It's a fundamental property of nature. This drove Einstein crazy. He famously said, God does not play dice with the universe. He wanted the clockwork back. He wanted determinism. But Niels Bohr replied, stop telling God what to do. If radioactive decay is truly random, if an atom spits out a particle for no reason other than pure chance, then the chain of cause and effect is broken. If the base layer of reality is random, then the future is not fixed. It is being written in real time, roll by roll of the dice. So are we saved? Does quantum mechanics rescue us from the prison of fate? Well, not so fast. There is an interpretation of quantum mechanics called many worlds. It suggests that when a quantum event happens, the universe doesn't roll a dice. It splits. In one universe, the atom decays. In another, it doesn't. Both happen. If this is true, we are back to determinism, but on a multiverse scale. Everything that can happen does happen. Let's bring this back to you and me and that comment you're thinking about writing. Whether the universe is a rigid clockwork Newton or a chaotic game of dice quantum, notice what is missing from both equations. Your brain is made of atoms. Those atoms obey the standard model of physics. If the universe is deterministic, your thoughts are just the inevitable result of chemical reactions caused by the breakfast you ate and the books you read. You didn't choose to watch this video. The Big Bang chose it for you 13.8 billion years ago. But wait, you say, I feel free. I can choose to turn this video off right now. See? You didn't turn it off. Was that because you chose not to, or because the neurochemistry in your brain determined you wouldn't? In the 1980s, neuroscientist Benjamin Libet performed an experiment. He asked people to move their wrist whenever they felt like it. He monitored their brain activity. He found that the brain initiated the movement milliseconds before the person was consciously aware of their decision to move. Your brain made the decision and then sent a memo to your consciousness saying, hey, we just decided to move the wrist. Act like it was your idea. This suggests that free will might be a very convincing user interface for a biological machine that runs on autopilot. This sounds depressing. If we are just biological robots or victims of quantum randomness, does anything matter? If a criminal was determined to commit a crime, can we blame them? Philosophers have a middle ground called compatibilism. It says, yes, your brain is a physical machine, but free will is just the name we give to the complex processing that machine does. Even if I am a computer that can learn, love, and dream. The fact that my choices can be mapped out by physics doesn't make them feel any less real to me. Determinism doesn't mean fatalism. Fatalism says, it doesn't matter what I do, the result is the same. Determinism says, what I do is the only thing that causes the result. You are part of the causal chain. You aren't just watching the movie. You are the screen, the projector, and the film. Is the future written? If you ask Newton, yes. If you ask chaos theory, yes, but you can't read it. If you ask quantum mechanics, maybe not, or maybe every future is written at once. Perhaps the mystery is the point. Whether we are dancing to the tune of the Big Bang or improvising in a quantum jazz club, the experience of living feels like ours. And until Laplace's demon shows up to hand us the script, we have to keep playing our parts. Thanks for watching.